Alright, with that, I think it's time to start, right? So, we're gonna cover two things today. One gonna be writing the formula for the compound, and the other gonna be naming the compound, right? So, naming is kind of tricky if you don't understand from the beginning, because you're going to start naming from here and then you're going to keep naming it until you are done with OChem 2. Right? So here we're going to start from the simple compound, alkane, for example, that's a chapter, right? And then in every chapter you're going to have a different functional group when you go to OChem 2 and also the last part of the OChem 1. So for every chapter, you're going to see the naming of that particular functional group, and then you're going to proceed to the reaction mechanism and other things. Right? So that's why if you don't get simple naming like alkane, it's going to be harder for the other compounds. Right? So make sure you understand very clearly. All right? Okay, before that, if you see three structures over here, you have the structural formula, you have the hybrid structural formula, and then you have the condensed structural formula, right? So if you see the first one, do you think it is familiar based on the Gen Chem class you have? You dealt with three types of formulas there. One was the molecular formula, other was the empirical formula, and then the third one was the structural formula. Right? So just let's see the structural formula. So what that means. In any formula, if you know each and every connection of atoms to have the compound, that's the structure. You know the bonding based on the structure you're going to write there. So for example, in the first one, you see the bonding between each carbon atoms there and also between carbon and hydrogen. Right? So each and every bond in the compound between the atoms are shown. Right? So this is called the structural formula. So for the hydrocarbon, alkane, that's what we're going to focus over here. Sometimes it's going to be a little bit messy if it is too large compound to draw all the bonds between them, right? So we simplify that. So it's going to be easier to write the bonding for the specific one, but for the normal type of bonding, we're going to hide that. Right? So this is called the hybrid structural formula. So if you see that, so this is the same molecule you have, it's not different. You have the same number of carbon, same number of hydrogen, right? So for alkane, it is obvious that you're going to have three hydrogens in one side, and whatever bond you have, say carbon, so you have the other bond to the carbon. So 1, 2, 3, 4 bonds to carbon. That is obvious if it is alkane, right? So for that, those CH3 parts you have, this, you're going to write this way. CH3. You don't show the bond between carbon and hydrogen because it is obvious, right? But you may have different bonds with the carbon or the non-carbon hydrogen, so you're going to show between them. So you have the bond shown over here, you're going to show carbon-carbon bond over here, carbon-carbon here, but you don't have any bond shown for carbon-hydrogen, right? CH2 or CH3 units are obvious. You're going to have the simple carbon-hydrogen bonding, right? So if you write it this way, this is called the hybrid structural formula, right? For the same molecule. Molecule is not different, same molecule, okay? And the other one, you're going to make even simpler than that. Then what you're going to do is, You're going to take each unit at one time, like CS3 for that. And then you have the CS2 after that. You're going to write CS2, right? And then you're going to have another CS2 after that. So you have that. And then you have CS3 at the end, right? So you're going to write that over here. So if you write that way, even without showing the bond between carbon-carbon, this is called the condensed structural form. So all are structural. Why? It's going to indicate where you have the bonding between the atoms, right? So it is obvious you're going to have first carbon over here. Even for the condensed, you have the first carbon over here. Now the next carbon is going to be linked into that. And then you have another carbon linked to that carbon. You have another carbon like that. You have in the sequence, the bond is implied already there. So you have the bonding that way. So this is called the condensed structural formula. Okay? So in organic reaction, we never write the molecular formula. Right? Because even if you have the same molecular formula, you're going to have the different isomers. Because of the group in different position in space, you're going to have the different structure. So we always going to write the structural formula when you write the reaction. Okay, that's why it is very important to do that. And another way to write that is line angle formula. So you're going to write this way. If you have the larger molecule, this is going to make it easier. You need to write hydrogen, carbon all the time. If you have the non-hydrogen carbon, then you're going to write the symbol of the atom. But for the carbon and hydrogen, you don't write any symbol, right? So, for example, this one over here. This is called the line angle formula, right? So, each line, you have one line, gonna have two terminals, right? 2 points, end points. So, end point gonna indicate carbon. So, you have carbon over here, and the other end point, you have carbon over there. So, it is obvious that these are bonded. So, one line gonna indicate two carbon atoms bonded together. Okay? So let's see over here. So I'm gonna write different color. So if you want to show this part, so this is the line you have, this line, right? And then if you're gonna write another part, say this one, so you're gonna have that, right? So that way you're going to write line between the carbon atoms in the molecule. So just connect depending on how many carbons you have. You're going to have that many ends to the line. Right? If it is linear chain without branch, what are you going to do? You're going to have, say, carbon, 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 right? 1, 2, 3, 4, 5. You have that. Then how do you write the line angle? So you cannot do like that. If you write straight, you're going to have only 2 carbons there, right? You're going to show that many carbons. So you're going to do zigzag. So 2 carbons, right? 3, 4, 5, 6. 1, 2, 3, 4, 5. You have 6 there, right? So you're going to write it that way. So this is the line angle formula for hexane. You have 6 carbon atoms there. Of course, you have hydrogen for each carbon. That is obvious, right? So that way you're going to indicate if you have larger molecules. Okay? So line angle is also the modified form of the structural formula. So that's the base over here. Good? Good. All right. Then, so the isomer I was talking before. So we're gonna first deal with the constitutional isomers, that's the name of that. So let's say you have the same formula. So you have C4S10 molecular formula, right? So depending on how carbon-carbon groups are linked in the molecule, you're going to have different structural formula, right? Say you have this way, you have CH3, and then you have CH2, and then CH2, and CH3. If you have group linked this way, then this is going to be the line angle for that, the same thing, right? Or you can write other way, the complete structure, you can write this way. You have carbon, 4 carbons there, right? And then you have all hydrogens on that. So this is the normal structural formula. And you can write the condensed. So this is going to be the condensed, right? So this is going to be normal structural formula. And then this is going to be the line angle. Same thing. Right? So you can write the same formula, same carbon atoms, same hydrogen atoms in different way. Suppose you're going to move one carbon to the other part, right? Let's say I'm going to move this over here in the middle. It will make the branch of that, okay? So this is going to become like that. So I'm going to draw that. So I'm going to have CH3, I'm going to have CS, and then CH3. So I'm going to have CH3 over here, right? So this central carbon going to have 1, 2, 3 carbon-carbon bonds, and then the hydrogen. So I can write this way hydrogen if you are confused, same thing, right? So the carbon, you have 1, 2, 3 carbons, and then 1 hydrogen bonded to that. If you count how many carbons there, you're going to have 4 in both cases, right? Both cases means this one, red box. Right? So both cases you have the same number of carbon 4, you have the same number of hydrogens 10. The only difference is the position of group in the space. That's the difference. Right? So these two are called constitutional isomers. The pair is going to be isomers. Sometimes you can have more than 2. So the longer the chain or more carbon atoms you have, more going to be the isomers. Right? So you can see in the table over here. If you have 5 carbons, you're going to have 3 isomers. Or you can say 3 ways of putting the groups in this space. You can see that way, right? If you have 10 carbon atoms, for example, you're going to have the 75. So the more carbon atoms, you have more chance of permutation, combination, right? So this is just a combination, different possibilities. So you have many ways of making that. So it's going to go exponentially when you have the more carbon atoms or increase in carbon atoms, right? So anyway, so know the meaning of constitutional isomers. Same molecular formula for all isomers are going to have the same formula, same carbon atoms, same hydrogen atoms, right? The only difference is how the groups are arranged in space. They're going to make isomer, okay? So now once we know that, now we're going to name the compound, okay? So how to name alkane? So that's the simplest compound hydrocarbon you have. So that's the chapter. So we're going to deal with that. Alkane nomenclature. Okay? So in Genichem, you had simple alkane naming, probably you forgot it, like methane, ethane, propane, like that, right? So we're going to start from there. And then we're going to go to more complicated molecules. Okay, the simple one. So the one thing you're gonna know is the base name based on the number of carbons you have. So we're gonna write based on the prefix and suffix. Okay. So the prefix gonna be like this: METH, ETH, PROP, BUT. So these are called prefix. So when you see the compound, you can read the number of carbons there, right? Let's say this is given, right? So you're going to count how many carbon atoms there. So you have 1, 2, 3, 4, right? So if you have 4 carbon atoms, the prefix is going to be BUT. That's the prefix. If you have 3 carbons, 1, 2, 3, the prefix is going to be PROP. So that's the one you're going to memorize. Right? There is no other way that. So count the number of carbons you have. Based on that number, you're going to choose the prefix. So you can take this table as a help. So count the number and then see the prefix for that. Okay? Since it is alkane, since you have all carbon and hydrogen, and you have the complete valency field with hydrogens, right? All single bonds with the carbon, then you're going to write ANE as a suffix. Okay? So if you see ANE in all these are the suffix. So you have ANE, you have the same ANE for all, right? Because all are alkanes. All are hydrocarbons. You have the single bond between the carbons and carbon and hydrogen, right? That's why it is ANE. If you have the double bond, it's going to be ENE, triple bond, YNE. We're going to deal in different chapter. But here, just the simple alkane, ANE. Okay? So that's how you're going to name. That's the first rule, right? So rule number 1, the simple rule number 1 is, you have the straight chain, you don't have any branching there, like you have CH3, CH2, 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 CH3, for example, right? So it is straight chain. You have the carbon-carbon-carbon linkage without any branch. That's a straight chain, okay? If you have that, the parent chain, the longest continuous chain is going to be the parent chain, of course, right? So you're going to put the prefix, that's going to indicate the number of carbon atoms. You're going to write that first, okay? So 1, 2, 3, 4, 5. I have 5 carbon. I'm going to go to the table before. So you're going to say PENT. That's the prefix for that, right? That's the prefix for 5 carbons, right? Then you're going to need the suffix. So for all, you're going to write ANE because you have the carbon-carbon single bond here, right? So you're going to have ANE, that's the suffix, right? That's the suffix. For all alkane, you're going to have the same suffix, ANE, right? So pentane is the name for that. If you have 6 carbons, for example, what's going to be the name? Hex going to be the prefix, ANE going to be the suffix, hexane. That's the name of that, right? So if you have this is called the normal alkane, right? Now rule number 2. So it is a little bit complicated, but it's not that hard. So let me write the same example. You have CH3, CS3, CS2, 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 pentane, right? Same example. So on that, now I'm gonna put one branch over there. Okay? That's the focus over here. Let me put CS3 over here. So with that, I'm gonna take 2 out. So you cannot have more than 4 bonds there, right? So that carbon gonna have 3 carbon and 1 hydrogen, right? So this is the molecule. So this is branched alkane. You have the branch CS3, right? That's the branch. We call branch for that. Okay? So now how are we gonna name it? So just take the branch aside and then name the other like rule number 1. There is no difference on that. Okay? So how do you name the group number 1? Rule number 1? You're gonna count the longest chain, which is parent, right? 1, 2, 3, 4, 5. So you're gonna write pent, N, right? Pentane. So that's rule number 1. Now you're gonna add a branch with that. Okay, so first you're gonna name without the branch, which is parent. You're gonna stay at the end. So now before this, you're gonna add the branching. So you have CS3. So if you have CS3 and then H over here, which is CS4, what do you call for that? Methane, right? So this is methane. So since this is the part, it doesn't have 1 hydrogen, right? So it is a methyl. So we're gonna write YLE. So AE gonna be changed to YLE, methyl, right? So methyl group, which is CS3. For the branch, you're gonna call YL, not YLE, YL, right? Methyl. So methyl is gonna be the branch. So you're gonna put that before the parent. So you're gonna write methyl pentane, right? So now one more thing. So methyl pentane, which type of methyl or in which carbon the methyl is connected? The first carbon, the second carbon, third carbon, right? So you're gonna indicate that connection over here. Okay? So now 1, 2, 3. If I go from the right, it's gonna be 3. 1, 2, 3. If I go left from the 3, gonna be 3, right? So I'm gonna write a 3 methyl pentane. That's gonna be the name. So now when you assign the number, you're gonna number the carbon in such a way that the branching gonna have the shortest number. Okay? So for example, if I modify this a little bit, and I'm gonna write, or I can give this example over here, right? So let's say this one. So this one, you have 1, 2, 3, 4, 5, 6. So based on rule number 1, xn, right? You're gonna write xn for that. That's the parent. Now you're gonna go to the branching. So you have CS3 over here. So you're gonna write methyl xn. Now you're gonna give the connection carbon number. Okay? So you have 2 ways of numbering over here, 2 possibilities, I mean. So from left to right, which is the red number, 1, 2, 3, 4, 5, 6, you can do that. Or you can go from right to left, which is the blue number. So you have 1, 2, 3, 4, 5, 6. Right? So now, when you go from the left, methyl gonna be on the 3rd carbon. The branched carbon, right? And then if you go from right to left, you're going to be at 4th carbon. So which one do you choose? The shorter number. So 3 is shorter than 4th, right? So you're going to go from left to right, not from right to left. Because going from right to left is going to indicate the longer carbon number or higher carbon number in the branching. You're going to stick with the shorter carbon number for the branching. You're going to go left to right, not right to left. Okay? Let's see the other one. This one. So the first rule, same thing. You have 7 carbon there, so you're going to write heptane for that. Right? Now you're going to see branching. So now you have 2 carbons instead of 1, right? You have 1 carbon over here and 1 over here. So you have the 2 carbon as a branch. So for 2 carbon, ethane. Branching, ethyl. So you're going to write ethyl heptane. Right? Now you're going to indicate the position of carbon. So if you go from left to right, you're going to have the 5th carbon that has the branch. If you go from right to left, you're going to have the 3rd carbon that you're going to have the branch. So you're going to stick with 3rd one. So you're going to go from right to left. So you're going to write 3. 3rd carbon, you have ethyl with heptane. Right? That's how you're going to do. Confused? Not hard, right? Alright. Yep.
Will we have an odd number that actually, or if it's the one in the middle, it's the same?
Same, yeah. If it's in the middle, if you have the same number, it doesn't matter. Okay. Alright. Yep.
How will we know the orientation? Like if I see 3-methylheptane and I know that it's on the 3rd carbon, how do I know if it's from right to left or left to right?
That's what you're going to count. So here, if you count from the right, 1, 2, 3, you have on the 3rd carbon on the right. If you go from the left, you're gonna be on the 5th carbon. So you're gonna stick with the less number. Okay? That's what you're gonna do. Alright, so now rule number 3. What if you have more than 1 branching? So we are going slightly a little bit complicated. Okay? So here you have 2 branches, right? You have 2 branches over there. Before you had only 1 branch. Now you have 2. So how do we name that? The starting point is going to be the same as rule number 1. There is no difference on that. Right? So figure out the parent chain. So the parent chain is going to be everything other than the branching. Or you can say the longest possible carbon chain, linear chain, is going to be the parent chain. Always. Okay? So here the longest possible is going to be this one. You have the 4 carbon continuous. Right? So that's the parent chain. Okay? So name for that. You have 4 carbon. What that going to be? Butane. Right? So this is called parent, you can call that parent. Now you're going to go to branch. So you have methyl, methyl. 2 methyl branches there. Okay? If you have 2, you're going to call di. If you have 3, you're going to call tri, tetra, and so on. Right? You can have as many branching as you like in the molecule. So you have a dimethyl because you have 2 methyl over there. Right? Now, like before, rule number 2, you're going to indicate the position for the branching. 2 methyl can be on the same carbon, it can be on the different carbon. Right? You're going to indicate that. which carbon you have the methyl attached. Okay. So now the same rule number 2, you're gonna stick with the least possible carbon number for the branching. Right? So if you go from the right, you have 1, 2, you have the second carbon, you have 2 methyl. So 2 for 1 methyl, another 2 for another methyl. So you're gonna write the position for each branch separately. 2, 2, why? You have both methyl on the second carbon. 2 methyl, 2 methyl, or 2, 2 dimethyl. Okay? So that's how you're gonna name it. Another example, you have this molecule over here. So now more than 2. You have 3 branches there. Right? So again, same rule. First, you're gonna find out the longest possible continuous carbon chain. That's the parent. Okay? So that's gonna be this one. So up to 10 carbon continuously bonded, that's the parent, right? So this is called parent you have. Now what's going to be the name for that parent? 10, you have a decane, right? So that's the name for 10 carbon, decane. So parent is done. Now you're going to go to the branching. Okay? So how many? You have 3. So you're going to have tri, since it is 3. 3 branches. Okay? Now, what is the branch there? Ethyl. Right? So you have 1 carbon here, 1 carbon over there. So 2 carbon linkage is going to be ethyl group. Okay? So how many ethyl you have? 3 ethyl. So triethyl. That's why you're going to have triethyl as a branch. Okay? So this is branch. So decane is parent. Triethyl is branch. Now, next thing, you're going to indicate the connection carbon. So, if I go from left to right, 1, 2, 3. So the first branch I'm going to have on third carbon, right? That carbon. If I go from the right, 1, 2, 3, 4, 5. So the first branch is going to be on the 5th carbon if I go from the right. So what should I do? Go from the left. Okay? So 3, that's the position of 1 ethyl. And then 4, that's for another 1. And then 6. So we are doing the red number over there, right? 6 is going to be another 1. So 3, 4, 6, triethyl going to be the branch. Decane going to be the parent. They're going to combine everything else. Right? That's how you're going to do. Good? Now, a little bit complicated than that. So, rule number 4. Alright? So, what if you have 2 different substituent or branches you can call? This is called branches, right? 2 different branches. Before, you had the same type of branch, methyl, methyl, ethyl, ethyl, right? So one type of a branch, many of them. Okay? What if you have different types of branches, both methyl and ethyl as a branch, for example. Right? So how do you write it? You're going to follow the same procedure. Right? Let's see this one. So you have the methyl. So this is methyl. And then you have ethyl. So you have 2 branches there, methyl and ethyl. Right? So the same sequence. You're going to find out the parent first. Longest continuous chain in the molecule. So I'm going to write this way. So from here, so this is the longest chain, this is parent. Okay? So how many carbons in parent? 6. So what's going to be the name for that? Hexane, right? So you're going to write hexane, that's the parent. Now go to the branch, like before, right? So you're going to write a both. Ethyl is one branch and methyl going to be the other branch, right? So ethyl and methyl, right? So position of carbon, same as before. If you go from the right, 1, 2, 3, you're going to have the branch on the third position. If you go from the left, you're going to have branch on the second position. So you're going to go from the left, right? So you're going to have the methyl in 2 positions. So you're going to have 2 methyl for that. And then you have the ethyl on the 4th position. You're going to write the 4 ethyl for that. You have ethyl on the 4th carbon, methyl on the 2nd carbon. These 2 are the branches. And then you have the hexane as the parent. Okay? That's how you're going to do. So, the tricky thing over here to know is why I wrote ethyl before then methyl. Make sure you know the sequence of that. Okay? You cannot write 2 methyl, 4 ethyl, hexane. Gonna be wrong. Right? So, you're gonna do alphabetically. Whenever you have the different substitute over there, see the alphabetical order of them. E gonna come before then M. Ethyl I gonna put before, then methyl. Okay, so remember that. That's the key over here. Other than that, it is similar to rule number 3. Right? So you're gonna have the alphabetical order if you have different types of branches in the molecule. Okay? Now you know the second example, right? So it's gonna be easy. Alright. So the 5th, yeah. Carbon 5. So you have 1 carbon, right? 1 carbon. So you're gonna have 2 remaining bonds. So it will be 4. 2 hydrogens. Yes, carbon 6 yes. Because you have only 1 carbon. All other 3 should be hydrogen, right? So hydrogens are just not shown over there. You have that way. Always, if you have single bonded carbon, the N carbon gonna have 3 hydrogens. All that. Good. All right. So let's say the 5th one. So now, this is also similar to 4th. So you're gonna find out the parent first, right? So that's gonna be the longest one with 7 carbon. So what's gonna be the name for parent with 7 carbon? F10, right? So that's the parent. So now we're going to see the branching, right? So, how many branches? You have 1, 2. So this is going to be methyl, and then this is going to be ethyl. So you're going to have 2 branches, right? So you have ethyl over here, and then methyl over there. So what about the position? So 1, 2, 3. 1, 2, 3. You have the tie. So from both directions, you're going to have the branch on the same carbon labeling. So you're going to break the tie, right? So how do you break it? Alphabetical order. If you have that, you're going to break with that. So ethyl gonna come before methyl. Ethyl gonna have the higher priority. You're gonna go to that direction. Okay, so that's the reason why you're gonna write 3 ethyl and then 5 methyl. Okay, you're gonna go from red number right to left. Right? Again, why? Ethyl comes before methyl. So you're gonna go that direction towards the ethyl. Okay? So that's the branch. So now the next thing is, what if you're gonna have the complicated branching? Instead of ethyl, methyl, the simple one, what if you have the branch something like this? Branching in the branching, double branching, right? Like say for example this. So here in this example, all are going to be the parent. So parent is not shown. Okay, so R is long chain, that's the parent. So all shown over here is the branch, the complicated branching. Okay, if you have that, so you're gonna have the name of that branch based on how many carbons you have. Like for the first one, you have 1 methyl propyl, gonna be the name for the branch, right? So why that? So you have the methyl over here. So you're gonna take the central point, the connection point. So let me write. Let me modify a little bit. 1, 2, 3, 4, 5, 6, something like that, right? And then let me put that branch over here. So I'm gonna have this branch connected over here, methyl there, and then like this. Okay. So here the branch I wrote is this. This is branch. So this is same branch as this one. Okay. So 1, 2, 3, 4. 1, 2, 3, 4, right? So the parent in your example is this R is parent this one. That's why it is not shown. That's the parent. Right? So it is noted by R. Can be any length. Okay, not a big deal. So now, how you name that? You can do the same way as before. You're going to write the parent first. What is going to be the name of the parent? 1, 2, 3, 4, 5, 6. Right? So hexane, that's the parent, like before. Right? Now you're going to go to branch like before. Right? So now it is complicated branch. Right? So how do you name that? You're gonna focus on the connection point between parent and the branch. Okay? So for that, you have 1 carbon to the other side, methyl, and then you're gonna have 1, 2, 3 to the other side. 3 gonna be propyl, right? So methyl propyl. So you're gonna have methyl as a branch for that, and then propyl was the parent for that within the branch. You're gonna call that, right? Now, in which position you're gonna have methyl? To the first carbon, right? So 1 methyl. So that's the branch itself. That's the branch. Right? So you can say like a sub-grouping of the parent, you can call that, right? Right? So you're gonna name the branch the same way you're gonna name the parent and branch for the simple molecules. So if you have complicated molecules, you're gonna have the parent like before, obviously, and then you have the branch complicated. So for that branch, you're gonna name the same way as the parent and branch combined together. Okay, and then you're gonna put together. So this is gonna be, so one methyl propyl gonna come over here, and then hexane after that. That's the thing, right? That means if you have the complicated branch, you're gonna name the branch as parent and simple branch together. Okay, another example, the same thing. Yep. Mhm.
How do we know that that bridge is separate and that it's not viewed?
The reason you know is always for the parent, you're gonna choose the longest possible chain. That can be the parent always, right? So you don't have any other 6 carbons in a sequence other than that.
Right. But in the group above it, how do we know that the R group is a methyl and a propyl is not?
You're gonna count from the connection point. That's gonna be 1 over here. 1, 2, 3, like that. So this is, you can call 1, 2, 3 as a parent, and then the other methyl gonna be the branch on that. Get it?
So if we were viewed, it would be going vertically.
So for bute, say if you have this line over here, gonna be the 1-methyl butyl. Right? Okay, so you're thinking like a highway. So let's say rule number 2. What do you do in rule number 2? So you're gonna see the parent, and then you're gonna put the branch there. So parent and branch, right? So think that as a simple rule number 2. Right? So within the branch itself, you're gonna have the parent, you're gonna have the branch there. So where to put the branch? The connection point. That's where you're gonna put the branch. Right? So that rule number 2 itself is gonna be the branch for the complicated one. Good?
I guess it must be that it's horizontal as opposed to like the ethyl group.
Mhm.
That example, 3 ethyl ethyl. How do we know that that's viewed? Is that 3 carbons or 4?
Because that is the thing. Because this is gonna be the starting point you have, because this is the connection point. So you cannot go from the end. If you don't have that connection point, yes, you're gonna go from the end. So the connection point is gonna be the starting point. From there, you're gonna go to the longest possible carbon, and then other gonna be the branch. Okay. All right. Yep.
Okay. Did she also consider, since the zigzag is 5 carbons, the one line, is that also a carbon or like that?
You mean like over here?
Yes.
So you're gonna have carbon over here, carbon, 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 carbon. You have carbon over here, and this is just a bond between a carbon. Good. All right. Yep.
How do you know what the combination
How do you know?
How do you know what the combination changes? Just by looking at
Just looking at R, they're going to be given. So R is just an indication. So you will not have R for the actual example. You're going to have the actual chain. Okay? Good? Alright. So how many minutes we have? Almost done? I thought we were going to finish this. Alright, rule number 6. What do you do? So you're going to do this, the complicated, right? Branching. So you're going to start 1 always from the connection point over there, right? So you have carbon over here, carbon over there, carbon over here, right? So this is going to count as a parent if it was the simplest one, and then this as a branch. So how do you write it? So this is going to be ethane, right? 2 carbon. Since it is branch, you're going to write ethyl for that. And then the other going to be methyl. And then what is going to be the position? 1. So you have 1 methyl ethyl. So that's going to be the branch. Okay? Good? Now it is clear? And then you're gonna have the parent chain, longest 8 carbon, this is octane. So this is the branch, and the other gonna be a down. So we're gonna connect all. Okay? So how many rules do we have? 7. So one more rule. Okay, so make sure you review all. You know all rules. If you have any confusion, let me know, okay? I'm gonna clarify the next class and I'm gonna come back.